Okay, Google, let me talk to the webinar host.
Getting the test version of webinar host.
Hey, welcome to the session today. I am here with your host Himanshu Sahdev to deliver the best of our thoughts to build your way in the field of embedded systems.
Oh, I'm glad you're here. Let us get started.
Thanks. Let me introduce you to the audience.
Yes, go ahead.
Himanshu Sahdev is currently working with HCL Technologies Limited as firmware engineer in the capacity of member technical staff. He have practical experience of integrating the DNA of IoT, board bring-up and bootloaders. Currently he is developing firmware for Intel platforms, writing UEFI BIOS applications and drivers and contributing to open source coreboot community as a part of HCL.
Thanks. So what is in our bucket for the audience today?
We are gonna understand the working of Arduino IDE, port manipulation, and we'll get our hands dirty with our first application. Let us start with our session.
So let me start with one of the open source electronic platforms available, Arduino. So as you can see on the screen, these are some of the available Arduino boards, and we are going to exploit one of these today as per our needs. So, but wait, what is an Arduino? It is not alone a microcontroller. It is a development board or a platform containing microcontroller plus onboard power supply pins, voltage regulator, crystal oscillator, power LED indicators, also a USB port to communicate to the PC. So in a nutshell, the main difference between an Arduino and a microcontroller is similar to the difference between a car and its engine. Let us see the I/O port structure for Arduino in specific to that Mega 328. As here you can see that all in blues are port B, all in greens are port C, and all in reds are port D. And we can easily tell from the previous slide that this PD0 to PD7, that is port D, maps to the Arduino's digital pin 0 to 7, see here. And from this PB0 to PB5 maps to Arduino's digital pins 8 to 13, from this to this. And from this PC0 to PC5, that is port C, maps to analog pins A0 to A5. Let us just talk about I/O. Input output comes in parallel, which is a bunch of bits at the same time, in serial, one bit at a time, in analog and in time. Today we are going to talk about parallel I/Os. So consider a reconfigurable port, as we have already seen that with Arduino that there are 3 ports, B, C and D. So consider a reconfigurable port, and in this port it can have 2 types of signals. We can have input which actually going to map or convert this 0.0 volt to 0, or 5.0 volt to 1, that is a false or a true, or that is a low or a high. We can also have output which will actually map this 0 to 0.0 volt or 1 to 5.0 volt. So we can see that this individual pins of this particular reconfigurable port could be an input or an output. So let us see how it works. One of the things software can do is to read from the port. So what happens is, when we read from the port, the value is then mapped from 0.0 or 5.0 volt to 0 or 1 onto this bus, and we can be able to read it. When we write to the port, the value is latched, that is 0 or 1 is latched into the register, and this register, if configured properly, will then be able to write to the pin. Now to control this reconfigurable port, we need a direction register. So like writing 0, or that means for input, writing 0 to the direction register, this latch in here will going to control this this pin, and this will actually control this whole logic. So writing 0 to this particular direction register, this latch here will turn this off and will be able to read only. Okay, that is 0.0 volt to 0 or 5.0 volt to 1. But writing 1 to this direction register, this latch in here will turn this on and will be able to write also. So like 0 or 0 to 0.0 volt or 1 to 5.0 volt. So port manipulation. So basically this is where you can access the lower level, or a faster manipulation method. It's a faster manipulation method for an IO. So these are 3 port registers, and DDR is the direction register we just talk about, which will set the direction as input or an output. So we'll initialize input and output using this. Port register is port is the register for the state of the output. Okay, so if we set this particular if we set a particular pin as output using the DDR register or the direction register, we can provide a 0 or 5 volt on that pin using this port register. Okay, and pin is the input register variable. It will read read the pin at this like all the pins at the same time. So yeah, but these 3 registers are there for all set of ports. We are having B, C and D. We are having 3 ports, so these are this DDR will be there for DDR B, and DDR C will be there for the C port. Okay, so let us just go ahead and get our hands dirty. So when you go in download and install Arduino IDE, that is Integrated Development Environment, you will be able to see this screen. This file option is like very much familiar, like other softwares. You can create a new file, open an existing one. You can open the recent files we have just opened and closed. The sketchbook is there when we save our programs, so we save it as a sketch. In examples, there are very basic examples already available, but these are using the abstractions somehow, using some of the already made so to say abstracted functions. We are just today we are just gonna focus on the lower level of the faster manipulation. So I'm just going into the preferences section, and I would like here to change this font size to 20 so that you'll be able to see what is I'm going to write while recording. And here's my sketchbook location. If I'm going to save this webinar 01 sketch, it'll going at this location. We can also change this. Okay, let's go ahead and let's go into the tool section. What we can see is we can have here is the board section, where we can be able to see a lot of boards already available using from Arduino, and we can easily add some other board which is not yet listed here, but we'll cover that up in the later sessions. Processor, as we have already seen that we are going to use at Mega 328, and it is already selected, but yes, port is not visible. So why if I'm going to write something, I'm not be able to flash that particular code into my hardware. So this is why we need a port, and it is not visible because I haven't connected yet. Let us connect, and now see, yeah, this is available. So after selecting these settings, you'll be able to see in the bottom lower of this software that Arduino Nano with that Mega 328P on this particular port is available. Now this white screen is our code area, and this is the button we're gonna use to verify, and this is for upload. So let us just start, hoping that you'll be able to see what is there. 20 font size 20 is very much okay, I guess. Let's go ahead. So okay, we can have we have actually 2 sections or 2 functions here. Like this is void setup, which actually run once whenever we press reset. Okay, whenever we press reset. And the other function we have is void loop, which is going to run over and over again forever. So this setup function is there, which allows us to initialize some things which we want to do it only once. We want to initialize our input and output only once. Okay, so what we're gonna do for today's lesson, I'm going to initialize pin number 12 as input and pin number 7 as output. Okay, so let us recall that port D maps on 0 to 7 on Arduino, and port B maps from 8 to 13 on Arduino. Okay, and we want to initialize this pin number 7 as an output. So we are going to leverage this DDR register for port D. So first of all, what we're gonna do, we to initialize it as an output, we want to write 1 or set a particular bit corresponding to the pin number 7 on Arduino in the direction register of this port D to initialize it as an output. So what I'm going to do, I'm going to write at that particular pin, which is 0x80, and how it is coming 0x80. Just consider an 8-bit register. Okay, here it starts from 0 to 7 on the port D2. So port D. So let's go ahead. 0 1 2 3 4 5 6 7. So 7th bit. For hexadecimal 1 2 4 8, I want to write 8 and 0. So I have wrote a 0x80 already. We can also use shifting operators like 1 left shifted by 1 2 3 4 5 6 and 7. So I can also write 1 left shifted to 7. Okay, and okay, so but wait, this is a very bad way of writing 1 to a particular bit or setting a particular bit, because we are writing just a bit like 1 on the bit 7, but we are also writing zeros to other bits, so we are affecting other bits. So let us just use this bitwise OR operator. What it will do is, while setting, this will set that particular bit number 7, and while leaving the rest of the pins unchanged. So and we also want to initialize pin number 12 as input, but this time this pin number 12 is on the port B of Arduino. So let us go ahead, use the DDR register for the port B, and just write a 0 or clear a particular bit corresponding to the pin number 12 in the direction register of the port B. Will initialize it as an input. So I'm going to clear that pin using this AND operator, bitwise AND operator, and a bitwise complement operator. This time I'm going to write 1 0. And why this is coming 1 0, let us just see. Just consider 8-bit register again, and we are going to go for pin number 12 starting from 8 9 10 11 12. So what I'm going to write 1 0. Okay, and we can also use shifting operators, so we can go ahead and 1 left shifted to 1 2 3 4. So we can also write 1, left shifted to 4. So we are done initializing our input and output. Now just come over to this loop section and let's just first think of what we want to do. Today for this lesson we just wanted to take an input from the push button, and we are gonna on the change of that push button's state, I want to blink an LED. So let us just take a state, because I'm going to read it. I'm going to set it as 1 as its initial state, and I'm going to read using this pin register we talked about. But so port B is what we are having as input, so we are gonna use pin B, but particularly pin number 12. So this is exactly the same here. So what I am doing is I'm writing the pin B register. I'm reading this using pin B, and I am going to get all of the inputs at the same time. So I am going to choose that particular pin number 12, whatever I've read on that particular bit, and I'm storing it into the state. And we can also now check if state is available. Basically, if not of the state, because we choose states, initial state is 1. So if state is becomes 0, if not of state, we can call blink LED function. But wait, let us just make this blink LED a reality. So what we want to do now, this is the we have already set our input output using DDR registers. We have already used the pin register to take or read inputs. Now it's time to provide an output to the LED. So we are going to exploit port register, and this time for port D, and I'm going to set that port particular pin number 7. This is exactly the same as this one. So I have set this particular pin, or I just give a logic high. Now I want to wait for some time, okay, so that we can able to realize that blinking. If I just write a high to a particular pin and then just low it, we will not be able to recognize when it goes high or when it goes low. So after a particular delay, I'm going to clear that particular pin again. So I'm going to write this, okay, and we again want to provide a delay. But wait is not already a function, so we have to create it. So just create another function called wait, and what I'm telling you here that this wait function I'm going to create will not be an accurate one, okay. So this wait function can be used to get a considerable amount of delay, so that we can be able to see, but it's not at all accurate. So the main thing I'm emphasizing in here, that we can also use inline assembly. So let me take load immediately into the R16 a value of 0, and then I'm going to take a loop that, let us say 1, just because we have already a definition for loop in here. I'm going to take a loop 1 label, and In this I'm going to decrease decrement this R16 value. After that, let us just go ahead and see if after decrementing we got a 0. If not, let us just go to this loop 1. Okay, so it is basically a kind of a loop. And but this one more thing to emphasize is whatever this will give you is not a considerable amount of delay yet. You'll not be able to recognize it. Will be kind of in microseconds maybe. So what we can do, we can because R16 was an 8-bit register, we can use we can make it as an 16-bit counter kind of. We can take advantage of an inner loop or outer loop kind of thing. We can use R17 here, and we can go on decrementing in the inner loop and then decrementing in the outer loop, but that would be kind of a complex for right now. Let us take int I is equals to 0 for an outer loop. I is less than 16,000, that would be much greater. Let's just divide by 4 plus I. Okay, so I'm going to take this outer loop, and as this is not in the good format, we can use this auto format option under tools. Okay, now it's easily visible in the readable format. Now what we can do is I guess we are all done. See, let's just go with the flow. Okay, we initialize our inputs and output. We initialize the state variable, and we read our pin. If we got state equals to 0, we are going to blink an LED. Blinking on port D, as we have an output on the port D itself, and we want a wait. I guess everything is correct. Let us just go and compile. Oh, let us try to upload this code and see if it works. Give me a second. Yes, it works. So basically let us just see. First of all, I'm having this circuit, and this is an Arduino Nano, and these are two pull-up registers. This green wire is for the 5 volt, and this small white wires is the ground common. This is the push button for input. This is an LED for the output. This is the pin number 12, which we initialize it as an input, and I'm going to read. We are reading from the state of this push button, and this is the pin number 7 as an output, which is used to blink this LED. So let us just see our output. When we press this button, we are right now able to blink this LED. So are we done? Not yet. I guess there's more, and about what we have already gone through these registers. What else? What we can do is, I guess we can go through address dereferencing method. Like for example, this is the port register. There is a port register for port B. It has an address, and I've been through the datasheet. That address is, let me define it as an address port B, and that address is 0x25. So let us take a pointer. Let me take a pointer, volatile uint 8 T for an 8-bit register, and we are going to call it as port B. Okay, and I think we need to typecast as well. Volatile uint 8 T pointer. So what we are doing here is we are dereferencing, address dereferencing method is, and why we are using the volatile. Volatile keyword is what tells my compiler that your services related to optimization is no longer required with this particular variable. So let us just create one. Let's just initialize one more variable on the port B, but this time as an output. So I'm going to set a particular bit. Let's just say port B pin 9, okay, as an output. Then we can have another function of somewhat like blink LED. I am going to create a DDR. Let's just go ADDR blink. Okay. In this, now we are not going to use these port registers like this port D. We are not going to use port B. We are going to use this one we have already created, port B, and I'm going to set that particular pin 0x02. Let me just write it here. We can also call 0x02 here in place of this one left shifted to 1. Okay, after that I'm going to call again this wait function. I'm going to clear this particular pin using this bitwise and bitwise complement operator. I'm going to use wait function again, and we are done. Let us just call this function from here, and let us try if it compiles and uploads well. Okay, we are done and it is working as well. So thanks for attending this session, and let me know if you are having any doubts. You can write it in the comment section. We'll get back to you, and thanks for attending.